In this video, we are going to look at another example of how to tell if an improper integral converges or diverges. So we want to determine if the integral from 2 to infinity of 1 divided by x times natural log of x squared converges or diverges. Okay, so before we do that, let's see what this integral represents. And if we let f of x be function 1 divided by x times natural log of x squared, we see that this is a continuous function on the interval 2 to infinity. This function is also decreasing. And so here's the approximate graph of this function on that interval. You can use Desmos to do it. You really don't need to know what the graph is to determine convergence or divergence. So this is what it looks like. It drops toward the x-axis as we move to the right and runs above the x-axis very close to it. This is the graph of this function from 2 to infinity, and the integral represents the area enclosed below the function above the x-axis after 2. So the improper integral from 2 to infinity, 1 over x times natural log of x squared is equal to the enclosed area. And we look at that and we see that since the region is above the x-axis, the answer will either be a positive number or positive infinity. Let's define this improper integral as a limit of proper integrals. So this is equal to the limit as t approaches infinity of the integral from 2 to t of 1 divided by x times natural log of x squared. And to evaluate such an integral, we want to use u substitution. So here's the computation of finding the antiderivative. The antiderivative of 1 divided by x times natural log of x squared. We let u equal to the natural log of x, and that means that du is 1 over x dx, and substitution here works perfectly. The integral becomes 1 divided by u squared du, and that, of course, is minus 1 over u. And then replacing u with natural log of x, we have minus 1 over natural log of x. And now return to the improper integral from 2 to infinity, 1 divided by x times natural log of x squared. Remember, we defined it as a limit. T approaches infinity. Of the definite integral from 2 to t, 1 divided by x times natural log of x squared. We just found the antiderivative, so this will equal to the limit as t approaches infinity of negative 1 over natural log of x evaluated from 2 to t. And that is equal to the limit t approaches infinity of negative 1 over natural log of t minus a minus plus 1 over natural log of 2. Of course, you can see that 1 over natural log of t approaches 0 as t goes to infinity. So the answer is 1 over natural log of 2. And we conclude that the improper integral from 2 to infinity 1 divided by x, natural log of x squared, equals to 1 over natural log of 2, or converges to 1 over natural log of 2.